Lesson 3: Mass, Balance, and Structural Limits. Accurately managing an aircraft's mass and balance is fundamental to safe operations. First, let's clarify mass definitions. The dry operating mass, or DOM, is the aircraft ready for service minus fuel and traffic load. When you add the traffic load, meaning passengers, baggage, and cargo, you get the zero fuel mass. Finally, adding takeoff fuel to the zero fuel mass gives you your takeoff mass. One of the most critical structural limits for swept-wing jets is the maximum zero fuel mass. All payload is carried in the fuselage, which pushes down on the center of the airframe. Conversely, fuel sits in the wing tanks, providing upward inertia and weight that counteract aerodynamic upward bending forces at the wing root. If your fuselage mass exceeds the maximum zero fuel mass limit, you risk overstressing the wing root structure if the wing fuel burns down completely. This is also why jet center tanks feed fuel first during cruise, saving the wing fuel weight to relieve those bending moments. Where that mass is balanced also changes how the aircraft flies. Loading an aircraft towards its aft center of gravity limit reduces the moment arm between the CG and the center of lift. This means less tail-down force is required to keep the aircraft in trim. Reduced tail-down force effectively lowers the total wing lift required, which decreases induced trim drag, lowers fuel burn, and increases cruise speed, though it slightly reduces longitudinal static stability. Because calculating these multi-million kilogram-meter moments manually can lead to errors, load sheets use index units. This uses a mathematical formula to simplify massive moment numbers into manageable small values for safer load planning.